Hey everyone, hope you're doing well. Today we're going to be talking about how to prove lines are parallel in geometry. So let's go ahead and talk about what parallel lines are. Parallel lines are lines that never cross each other, okay? They're lines that no matter how far they stretch out, no matter from negative infinity to positive infinity, no matter how long the lines are, these two lines are never going to cross from each other. And you might remember from algebra that parallel lines are lines that have the same slope. So let's go ahead and look at what sort of the formal definition is in geometry of what parallel lines are. So here we have sort of the formal definition of what parallel lines are in geometry. So we have two non-vertical lines. We know that two non-vertical lines are parallel if and only if their slopes are equal, okay? And two vertical lines are parallel. So if they're not vertical lines, kind of like these, the only way we can prove that they're parallel would be to find their slopes and show that they have the same slope. If we can do this, we know that those lines are parallel. If we have two vertical lines, we don't really need to do any work. We know those are parallel, okay? If we have two lines that are exactly vertical, we know that those lines are in fact parallel. So there's two ways that we can actually prove that lines are parallel in terms of showing that their slopes are equal. One of them involves using the slope formula. Okay, and the slope formula is m equals y2 minus y1 over x2 minus x1. This is a slope formula that you should have learned in geometry that requires us to know 2 points. We have one point x1 comma y1 and another point x2 comma y2. And the y values of these points we subtracted from each other, we put those on the top, and the x values we subtract those from each other and we put those on the bottom. A lot of times you might have also heard that slope is rise over run, which you'll also get a chance to see how we use that as well to find some of the slopes of certain lines. So let's go ahead and let's look at an example of a geometry problem that reads, compare the slopes of the lines of y equals f of x and y equals g of x to determine if each pair of lines is parallel. So here we have a table that has the values for two lines. These are the x and y values for our first line, and these two would be the x and y values for our second line. So they share the same x values, but they do not share the same y values. Essentially what we have here is a bunch of different points. Each of these represent points. So 0, 20, 1, 35, 2, 50, and 3, 65. These are the points for my first line, which we call f of x. The points to my second line are 0, 22, 1, 37, 2, 52, and 3, 67. And we ignore really these middle numbers because those are the y values to my first line, and these would be the y values to my second line. So really what we have to do here is we just pick 2 points from each line in order to plug into our slope formula. So let's go ahead and let's write down our slope formula here. As mentioned previously, it's y2 minus y1 over x2 minus x1. And we're going to pull 2 points from each function. So for f of x, I'm going to take the points 0, 20 and 1, 35. I'm going to use those points. For g of x, I'm going to take the points 0, 22 and So we'll do 0, 22, and we'll do 1, 37. And we are going to use these points to find the slope of each line by using the slope formula. So we're going to use the slope formula twice. And what we want to see in the end is, do these two lines have the same slope, or do they have different slopes? If they have the same slope, then we can in fact prove that these two lines are parallel. So let's go ahead and let's get started with finding the slope of f of x. The slope of f of x. So if my points are 0, 20 and 1, 35, then here are my x's, x1, x2, here's y1, y2. We're going to go ahead and plug that into our formula that we see there. So at the top, I should have y2 minus y1, which would be 35. Minus 20. And on the bottom, I would get x2, which is 1, minus x1, which is 0. 35 minus 20 is 15. 1 minus 0 is 1. So I know f of x has a slope of 15. Okay? So that's what I've found out so far. I now know the slope of f of x. So now let's find the slope. Here's my slope of f of x. Let's go ahead and do the same. We're going to do the same for the slope of g of x. We're going to move off to the side a little. Let's find the slope of g of x. Okay, and we're just going to use those 2 points that we have there. So we have 0, 22 and 1, 37. Did I have to choose these points from the graph? Not really. I could have chosen any other points, but we're going to go ahead and make sure we choose the same 2 points in this case that had to do with x being 0 and x being 1. And then my y values, y1, y2. I always like to label my points. It makes it easier for me when I'm plugging them into my formula. Again, my formula is right there up at the top. y2 minus y1 over x2 minus x1. So I write m equals. All right, so y2, that is 37 in this case, minus y1, which is 22. On the bottom again, you're going to notice we have x2 as 1, x1 right here as 0, 37 minus 22, we get 15 over 1. So our slope is also 15. So, because these two lines had the same slope, both f of x and g of x having the slope of 15, I know that f of x and g of x, I know that both of these are parallel. So if they have the same slope, we know they're parallel. If they have different slopes, then we know they're not parallel. So we can actually prove that these two lines, we have proven that these two lines are parallel by showing that their slopes are the same. So this is an example of how to prove that they're parallel by using the slope formula of m equals y2 minus y1 over x2 minus x1, kind of highlighted in yellow here. Now let's look at an example of a problem where we're actually going to use the other formula known as rise over run, which requires a little bit less steps, a little bit of less sort of calculations, because really what we're doing for this is we're going to be counting. And we're allowed to use the formula of rise over run whenever we have the visual representations of those lines. So whenever we have those lines actually graphed out, we can use rise over run. Okay. So using the rise over run formula, we're going to go ahead and we're going to pick two lines and we're going to test to see if they are in fact parallel. So for this one, we're going to go ahead and we're going to look at line P and line Q. Here we have line P and line Q. And there's no real specific reason why I chose these lines. It's just, for me, off of my eye level right now, the way I see it, these two look like they have the best chance of being parallel. So what we do is we pick 2 points on each line. So I'm going to pick this point right here, and we'll go with this point down here for line P. Okay. And then for line Q, I'm going to go ahead and go with its y-intercept, and I'm going to pick this point right here. And now let's go ahead and let's find the rise and the run of each one. So for line P, it's rise over run. Rise over run. And hopefully you kind of remember a little bit of this from algebra. Rise, we're talking about the vertical movement. How much did this move up or down? Run is horizontal movement. How much is it moving to the right or to the left? And we're really talking about what does one point need to do to get to the location of the next point. So here I can see that this point goes down 1 space and to the right 3 spaces. Well, that vertical movement of going down 1 space is what we call our rise. And because it went downward, we actually make that negative. So this would be a -1. So I'm going to go ahead and write -1 here. That's my rise. My run is that horizontal movement, so it went to the right 3 spaces. Because it went to the right, it stays positive. If it goes to the left, it would be a negative value. So for line P, my slope just ends up being -1/3. So now let's talk about for line Q. And again, we're going to use the same formula. M equals rise over run. And we're just going to find what was our rise, what was our run. So again, this one looks like it goes down 1 space to the right 3 spaces. So again, our vertical movement, that's a -1. Horizontal movement, we go to the right 3 spaces. And these two do in fact have the same exact slope of -1/3. So I know P is parallel. Remember, geometry, we also write down that 2 lines are parallel by using these 2 vertical lines. P is parallel to Q. We can actually do the same to the other lines in here, and you'd find out that P and Q are the only lines that are parallel in this case. So hopefully now you feel like you have better of an understanding of how we can prove that lines are parallel. Again, we make use of the slope formulas. The main one being y2 minus y1 over x2 minus x1. And then whenever we have graphs, we like to take advantage of the graph and use rise over run instead. It seems to be a little bit faster, okay? Now if you'd like, I recommend watching this next video where we're going to get into perpendicular lines, and in a similar way we're going to use the same 2 equations that we used right now, or really we're just going to use rise over run because we're going to be looking at graphs, but perpendicular line slopes are also related. So watch this next video where you'll learn how perpendicular line slopes are related and how you can prove that lines are perpendicular. But as always, I just want to give you a quick thank you for watching these videos. I hope you continue to learn, and I'll see you guys next time.